Welcome to qnawire.
For this problem, we will let capital M be the mass of the Sun and little m be the mass of Venus. For the circular orbit of Venus about the Sun, the force acting between the Sun and Venus is given by G, capital M, little m over r squared. R here is the radius of the orbit, and this is equal to m times the normal component of the acceleration of Venus about the Sun by Newton's second law. And since this is centripetal motion, this is equal to mv squared over r. So what this means is that G times m is equal to r v squared. So given our data for Venus and the Sun, we have that the radius of the orbit r is equal to 108 times 10 to the 6 kilometers, which is 108 times 10 to the 9 meters. V, the speed of the orbit, is 126.5 times 10 to the 3 kilometers per hour. And this is equal to 35.139 times 10 to the 3 meters per second. And G times m is equal to 108 times 10 to the 9 multiplied by the mass of Jupiter, so actually in this case we write Gm as rv squared, so we just take r and multiply it by v squared, 35.139 times 10 to the 3 in SI units, which is squared, so we get Gm to be 1.3335 times 10 to the 20, and that's meters cubed per square second. So the first thing we will do is find, for part A, the mass of the Sun. So the mass of the Sun, remember, is capital M. And capital M is simply Gm over G. So this is equal to 1.3335, our value for Gm, which we just found, times 10 to the 20 meters cubed per square second over the value for G of 66.73 times 10 to the minus 12 in SI units. And so we get the mass of the Sun to be 1.998 times 10 to the 30 kg. So that's the mass of the Sun in SI units. For part B, at the surface of the Sun, we want to calculate the gravitational acceleration. So at the surface of the Sun, we have r, the radius of the Sun, is 695.5 times 10 to the 3 kilometers, which is 695.5 times 10 to the 6 meters. And we have that G m times m from our initial equation above over r squared, the radius of the Sun, squared, is equal to m times g. So the mass of the object on the surface of the Sun experiencing the gravitational acceleration cancels out, and we get that the gravitational acceleration on the Sun's surface, little g, is equal to G times m over r squared. And then we can substitute these values in. So this is 13335 times 10 to the 20 over r squared, which we already calculated in SI units, to be 695.5 times 10 to the 6. And that's squared. Hence we get the gravitational acceleration at the surface of the Sun to be 276 meters per square second.